Hello everybody, Root Beer here. I'm going to be starting another contest, this time the 2004 Galois contest. So the Galois contest, the 2004, it's the grade 10 level contest, but it's not like the Cayley. The Cayley's multiple choice. The Galois competition requires written solutions, not unlike the big scholarship paper, which is the Euclid written in grade 12. Okay, this was the second year of the Galois competition, so if we take a look, the layout isn't exactly the way we would expect it if we've seen more recent Galois, but it's an improvement over the previous year, 2003. They had sort of little bonus problems at the end, which, as you can see, they do not have this time. Still 4 questions, so they're keeping the format the same, and that's great, and I believe we still have an hour to write the competition. So, yeah, not a whole lot else to say. As I recall, calculators are allowed, but honestly, you won't need them for the most part. They try and shy away from that, maybe a little bit, so it's good to have them on hand. And I believe that policy is still around today, that you can still have your calculators. Yeah, there's not a whole lot else I want to say. As usual, if you'd like a copy of this contest, you can click the link in the description, and you'll get a copy for yourself to try. If you want to try, problem 1 on your own and then come back, or if you want to jump straight to problem 4, that's great, and I'll have a video up for problem 4 in no time. So in the meantime, let's take a look at question number 1 here. So it's broken down into 3 parts, and remember, we need to justify everything we're doing at each step. Okay, the Galois group is giving out 4 prizes valued at $5, $25, $125, and $625. Okay. Part A, the group gives out at least one of each type of prize, so there's a $5, a $25, a $125, a $625 already given out. If 5 prizes were given out, with a total value of 905, how many of each type of prize is given out? And of course, explain how you got your answer. Alright, so we've got 5 prizes, but 4 of them are accounted for because we have one of each of these 4 different types of prizes is given out. Okay? So really, there's only the 5th prize. Is it a $6.25? Is it a $5? Who knows? Okay, that's what we're going to try and find out. So I might say, well, I might first change to black. It's important to have the right ink. So there are 4 kinds of prizes. One of each is given out. So the 5th prize is left to determine. Okay. And I'd say something like the first 4 prizes account for $5 plus $25 plus $125 plus $625, and that's equal to 30 there, plus the 225s is 50, so 30 plus 50, that's 80, plus, and then 6 plus 1 is 7, so it's $780. So this leaves 905 minus 780, which is a difference of 125 for the last prize. Okay? So we've determined that 5th prize must be a $125 prize. So I'd probably sum it up, one $5, one $25, two $125, and one $625 prizes were given out. Okay. So that gives us A part. Now let's take a look at B part. If the group gives out at least one of each type of prize, so we already know that that's going to account for $780, and 5 prizes in total, so maybe one other 25, or maybe it's another 125, who knows, determine the other 3 possible total values it can give out. Okay. And of course, explain how you got your answer. Okay. Just because it may direct how we do the rest of the problem, this is always a good idea to read all the parts. I'm going to read part C as well. There are 2 ways in which the group can give away prizes totaling 880, while making sure to give away at least one and at most 6 of each prize. Determine the 2 ways of doing this and explain how you got your answer. Okay, so it's not exactly, doesn't appear to be related. Although giving away one of at least each prize does account for 780 of those dollars. Okay. But that's not really going to affect how I do B, so we're just going to jump right back in and do B. So I might say something like, we saw in part A that one of each kind of prize accounts for $780. The 5th prize could be, it could be $5, and then that would give us $780 plus $5, $785 as our total prize money. We could have a $25, so we'd have $780 plus $25, and that would give $805. We've already seen the $125, so we know he's going to give us $905. And lastly, the $625. Let's see if I can do this without getting my calculator out. It's 500 more than 125, so it'll be 500 more than this, so we should have 1405. So I'm just going to circle the new ones, the ones that we didn't already know. And I'm going to sum up a little bit. So 785, 805, and 1405 are the other possible totals. Okay. Doesn't have to be super fancy. What we've done is we've explained our reasoning. We said, we had this prior knowledge in part A, 780 is accounted for. You've got one more prize left, $5, $25. These are the amounts we could have. So these are the total prize values we would get, and we have singled out the ones they asked for, the other 3 total amounts. Okay? Simple as that. Nothing really strenuous needs to be done there. Just explain how you got your answer. You don't have to be really, really detailed. I mean, at best, part B is maybe worth 4 marks. More likely, it's worth 3. Okay? So we got the 780. That's probably worth a mark. Each of the totals is probably worth a mark. And then maybe summing up your answer is probably worth a mark. Okay, now we already read C, but that was just to tell us, do we need to take a certain direction with B? I'm just going to reread it again. 2 ways which group can give away prize totaling 880. At least one of each prize, at most 6 of each prize. Determine the ways of doing this, and explain how you got this. And we know that there are going to be 2 ways to do this. Okay. So I might say something like, once again, since we are awarding at least one of each kind of prize, $780 is already taken care of. That leaves 880 minus 780, $100 left to make. Okay, so we have to make $100. Now, another observation I can make is one of each prize is already given. So at most 5, because that's 6 minus 1. We're told at most 6 of each prize, but we've already guaranteed 1 of each prize. So at most 5 of each prize can be used to make the $100. Okay, this may or may not become an important issue. I don't think it necessarily will. I don't think there'll be a fake out where, if you accidentally use 6 5s, you do get a 100 with some other numbers. I don't think that'll be the case. But first things first, both $125 and $625 prizes are too big. Okay. So we can only use $25 and $5 prizes. Okay. So, is there any other way to narrow this stuff down? I don't think so. Let us make a chart. Based on number of $25 prizes we can use. And fill in the rest up to $100 with $5 prizes. Okay, so I don't quite know, there's no way to say, aha, we can definitely use 3 25s and 5 5s, which actually would work. But there's no sort of obvious way to say that's the way we've got to do it. So what I'm going to do is I'm just taking the largest prize number, and I don't feel like I need to justify that. I'm just taking the largest prize number. I'm going to say, we can have 5 25s. How many more 5s would I need to get 100? I could have 4 25s. How many more 5s would I need to get 100? 3, 2, 1, 0. Okay? And so in that way, since we've narrowed it down to either $25 prizes or $5 prizes, we will eventually get our lists of hundreds, because we can't do anything with 125s and 625s, and we are told that there are 2 ways to make the 100. Okay? So that's what we're going to do. We're going to make a chart that way. So number of $25, I'm going to have what's left, and I'm going to have my resulting number of $5. So I'm going to have 0, 1, 2, 3, 4, or 5 of them. If I used 0 25s, there'd be $100 left, and $100 in 5s is 20. 100 divided by 5 is 20. If I used 125, I'd have $75 left that I need to make up with $5. So I would need 15 $5 bills. If I had two 25s, that would be $50. Take that away from 100, you'd still be left with $50. That takes 10 5s. You can sort of see a pattern. You might even be able to go on autopilot and complete this thing. 5, you'll have, with 4 25s, that's the full 100, so we won't need any $5 left. And 5 25s would be 125. It's too much. Okay. So which ones use at most 5 25s? Well, all of these. Which ones use at most 5 5s? Just these two. So my solutions are our two ways are we could have one $5 because we have to have one of each. We have 125 plus an additional 4 25s, 5 25s, one $100.25, and one $6.25. Okay? And if you wanted to, you could grab your calculator and we could double check. 5 plus 25 or 5 25s. Oops. 4 5 plus a 125 plus a 625, it really is 180. So I've double checked that I did do this right. I didn't make a sort of a logic error somewhere in there. This really does work. What's our other method? So that'll be the one corresponding to this. So we'll have 5 $5, but we already gave away one. So we have 6 $5. We'll have 125 that we already gave away at the very start. That's part of the 780. Plus these 3. So that's 4 $25. One 125 and one 625. Okay. And we can double check. That's 30 plus 100. So that's 130. Plus 125. So that's 255. 55 plus 25 is 80, and 200 plus 600 is 800, so that really is 880. And that wraps up question number 1 for us. Quite nice and neat. And we've explained everything, what we were doing. We got a nice chart, and we did get our 2 ways, and we really did everything they asked for. So in the next video, we're going to take a look at question number 2. It looks like it's got some semicircles, and it also has 3 parts. Hopefully you guys will download a copy of the contest, try it for yourself before going and watching. But either way, I'll see you guys in the next video.